All right, hello everyone. We are the Duke OIT AI chatbot team. So I'm Jonas Belay.
I'm Lauren Pelvanian. I'm Karen.
I'm Jonathan.
I'm Natasha.
All right, so before we start, we would first like to thank our tech team. So Stephen, John, and Liz have been really helpful with getting us all the resources we need. And Sherry and George have been really helpful when it comes to actually working with Azure and Ruby services. Next, we'd like to thank our stakeholders. They've been super helpful in just defining the goals from the very beginning and just the general scope of the project. And finally, we'd like to thank our sponsor and technology partners at Microsoft. Anna has been meeting with us every Monday to help us going over the Azure services, and Jeff has just been there to answer any questions we've had. So first, we're going to start with a general project overview and then move into the current state of our bot right now. And then we're going to go into some challenges and roadblocks, and finally, some future recommendations for people who are going to be taking over the project after we're done with it. So now I'm going to pass it over to Natasha.
All right, thank you. So first of all, we wanted to essentially define the problem that we were asked to solve for you guys. So essentially, if you go on the OIT website right now, in the corner of the screen, there's a little button that says live chat. And if you click on it, you are connected with a person who's there to answer any questions that you might have related to OIT issues. But we were asked to help create some more efficiency with this process by automating some responses and essentially supplementing what we have right now with a person. We also wanted to alleviate a lot of the human workload that the service desk is feeling right now. We wanted to be able to give OIT the chance to focus on some other areas that they might want to work on. So our mission in the end was to use natural language processing to support accessing knowledge at Duke. So we had three main goals throughout the creation of this project. So the first one was, again, to augment the live chat. We wanted to really be able to supplement what we already have working with the service desk through ServiceNow. So we wanted to implement a bot to kind of augment what we have right now. We wanted to create a bot that was also very task-oriented, that could actually perform actions for users, such as creating a mailing ticket or resetting a password. And also we were looking at implementing this bot beyond just OIT. We were thinking of other departments where this could be used, whether that's housing, admissions. We were just looking at where else could a bot like this be used, and how can we really start dipping our toes into AI at Duke. So these were the four main tools that we used during the creation of this project. So we are essentially using Microsoft Azure AI services. This is a relatively new platform, but this was our platform of choice to actually create a bot, and most importantly, add functionality to the bot to get it to do what we wanted it to. We've been using OpenAI as like the language base for our bot. So this is like essentially the base framework that we're using. We're also using a bot framework composer to configure the different settings with the bot and change it as we see fit. And finally, we're using a bot emulator to be able to simulate the chat itself as though we were a normal user using our bot, and therefore we could create a trial and error process to see what we wanted to change. And now I will hand it off to Jonathan, who's going to talk about where our bot currently is.
Thank you, Natasha. Now, I will speak a little bit about our current development with the bot. We, as Natasha mentioned, decided to primarily focus on OIT's knowledge base. As you can see here, through an API call, we have gathered OIT's knowledge base, which is a lot of very non-digestible information with a lot of HTML tags, which we need our bot to actually process. We managed to clean up this information using Python, as you can see here. Previously, it was a big mess that we were able to clean up through some HTML parsing using Python and then digest it into our AI model. We are utilizing Azure's bot framework composer to build a bot that, through user intent, is able to deliver an appropriate response. Bot framework composer is running on C#. As you can see here, depending on the intent that the user has with our chatbot, it would trigger separate mechanisms known as dialogues that would begin a chain of conversation. The AI model we are building off of is OpenAI's GPT 3.5 Turbo, and we're calling the API through an HTTP request within Composer. Within the Composer, as you can see, we modify certain parameters known as, for example, the system message, which instructs our bot how it's supposed to behave. We also trained our model on our data by manipulating parameters such as temperature, which determines how creative our model's responses are. We store our data in what Microsoft refers to as a blob within their blob storage service. The blob is then indexed into through another Azure service known as Cognitive Search. Within Cognitive Search, we can implement different skills with our bot in order to manage and ingest our data. One of them is known as semantic search, which uses deep neural networks to provide relevant results based on semantics as opposed to lexical analysis. Rather than searching for words within our data and seeing if they match what the user needs, we're able to actually extract meaning from every sentence that the user types within our chatbot. Now I will go over a short demo of the current bot that we have working. We are currently testing our bot locally in Microsoft's Bot Framework Emulator. Our chatbot itself has interactive elements. As you can see, as you join the chat, you are greeted and you are prompted to type in person whenever you are in need of human assistance. When the user enters a question, it's passed through our model as a prompt, which then returns a completion if an appropriate answer can be drawn from our data. When a completion is returned, the user is asked whether or not their question has been answered. If a question is irrelevant and has nothing to do with OIT data, the bot simply responds, "I do not find any information related to the question within the documentation I have been provided." When you need human assistance, you can simply type in person and you'll be asked to click a button which links you to the current chat that OIT has in place within their website. Another feature within our chatbot is session expiration. If the user has not interacted with the bot for a certain amount of time, we will check in on them. If no response is further given, the chat will automatically end and it will thank the user for using the bot, enabling the user to then give us feedback. That feedback is then sent to us and stored in the service I mentioned earlier, known as Microsoft Blob Storage. Through Azure's Logic App service, we can make an HTTP request to our Logic app, which will send an email to the user with a copy of their chat session attached as a document. Every chat session is stored within our blob storage, where every message is a JSON file within its specified folder. Now I will hand it over to Lauren to speak about some of the challenges and roadblocks we have faced.
Okay, so I'll be talking about some of the challenges that we faced through our development this summer. So starting off, we first had the idea to create a mailing list automation chatbot. This was like the first use case that we focused on for our bot because currently the problems that the IT service desk faces with the mailing list manager, or also known as SIMPA, is the manual process of approving mailing lists. So every time a mailing list is created, it needs to be sent as a request to ServiceNow and create a ticket. And that needs to be manually approved each time by an IT help desk analyst. So that's like a very time-consuming process and often involves a frequent back and forth where if a mailing list is rejected, it can trigger a few rounds of emailing between the user and the IT help desk, which is just overall very time-consuming. So we thought that creating a bot with two key features, one to extract relevant information, to be able to reject the non-compliant list directly within the dialogue itself rather than needing to create a ticket. And then secondly, with a machine learning model to predict the title or the name of the mailing list's approval or rejection. We thought these two features would help increase the efficiency of the IT help desk. And we kind of came to this idea alongside Paula, who's one of our stakeholders. But the main obstacle we ran into was that the complexity of the data set that we wanted to use for SIMPA was out of scope for our timeline. So this would be a potential future project. Instead, we focus some more of our time into trying to integrate our bot into Fixit. Fixit is a Code Plus project from last year, which one of our mentors, Sherry, actually worked on last year. And it was a like an IT issue reporting website, but The main reason we decided to integrate into this website is because it already had features like Shibboleth and authentication working, and it was already being hosted. So we thought that we could just kind of piggyback off of these features on their front end to be able to host our bot more quickly. So the two main areas of functionality we wanted to add to this web app were firstly the Azure API calls. So similarly to how Jonathan previously demoed, we could have an API call to the Azure bot, be able to pass in a question and then retrieve an answer from the API. And then through this, we wanted to be able to display the bot's response and then implement a feature called multi-turn answering, which is a way for the bot to take the entire context of the conversation when answering a question rather than just taking each question one by one. And then secondly, we implemented some Rails databases to be able to store questions and answers from the user and then to be able to sort feedback. So a quick demo of what that looks like. So you have the chat interface in the center of the screen where you can type your question in the little search bar, and then it displays like a chat. And then on the right, you have options to end the chat session once you're complete. And then, or you can speak to an IT analyst similarly to previously if you wanted to speak to a person. So once you press end chat session, an email is sent to the user and a confirmation page is loaded. And then the user has the option to send feedback, which again is stored in our Rails database. And then just a little sample of that email looks like this, just so the user can keep track of like what they tried during the chat session. But ultimately, through talking with Microsoft, we decided that this prototype web app would be less efficient to focus on compared to using some of the Microsoft Azure platform tools directly. So we decided to hold off on developing the front end ourselves through Ruby, and we decided to use more of the Azure services to add functionality to our app. Okay, so now I'm going to pass it off to Jonas to talk, or Karen, sorry, to talk more about the future steps.
Thanks, Lauren. Thanks. So we kind of broke down our potential future steps into 5 different sections: accuracy, GPT-4, and ServiceNow integration. And then I'll pass it off to Jonas to talk about feedback learning and other data resources. So first, about accuracy, one of our main goals throughout the entire summer was reducing and eliminating hallucinations. And hallucinations are just basically the phenomenon where AI like makes up data on its own. We absolutely did not want the AI chatbot to be able to make up like stuff on its own and to give people false information. So throughout our time, we worked a lot in trying to figure out whether or not we can kind of adjust that depending on the prompt engineering. So for example, a system message, or the message that we're giving the bot to give it its identity, as well as the temperature settings, which tells about how creative it gets to be. And we actually very recently made progress in figuring out how to integrate both semantic and cognitive search. So this basically refines like the search. Whenever we type in a question, the bot is actually understanding what we mean instead of just searching through like keywords. And I think we made this progress like pretty late into the summer. So this is something that we hope to continue adjusting and maximizing. So next, about GPT-4, currently we're using GPT 3.5 Turbo. And currently GPT-4 is an available model, but it's only available for selective enterprise use. This model is supposed to have improved context memory and function calling. So in the future, if they do decide to expand the use of that, we actually did receive access to GPT-4 very recently, again, like literally this week. So we didn't really have time to do too much like testing involving GPT-4, but hopefully in the future, this is something that we can try more. Next, about ServiceNow integration. Currently, the handoff to human with our bot is just a button that links to the current ServiceNow website. We hope that in the future, we can have a better handoff to human, for example, sending the chatbot history or the chat history to whoever is helping the user so that, it streamlines the process. And we hope that the bot can directly create and send tickets to the service desk instead of them having to go through 2 separate processes, that the bot can just do that on its own. We also hope to be able to filter the knowledge base. Currently, there are a lot of information about Duke Health or other information that might distract from the accuracy of the bot. In the future, we hope to kind of filter this and make the database or the knowledge base more specific to the specific, like, for example, OIT, instead of having like Duke Health information. And we also want to be able to update the database periodically, if there's new policies or added new things into the knowledge base. We want to be able to have that update every so often.
All right, so the next feature step we're going to be talking about is feedback learning. So as you saw in Jonathan's demo, we currently have a place where a user can leave feedback at the end of their conversation, and we are storing that data. But the next step with that would be to take that data and automatically have the bot adjust its responses based on the user feedback. So whether that just be like a general, this conversation was good, this conversation was bad, or specific comments within the little feedback box. And finally, some other data sources. So one of the things we wanted the bot to do from the very beginning is to have contextual awareness. So this is not only including just knowing that you are a Duke affiliate, but also knowing if you are a student, faculty member, teacher, etc. So the bot can better assist you. And the next one is simplifying uploading new data sources. So as Natasha said, we wanted to make this bot go beyond OIT into other organizations such as Duke Stores, housing, admissions, etc. So to do this, we want to make the process of uploading new data really easy, because we know that other organizations may not have the same organized knowledge base that Duke OIT does. And thankfully, Azure makes that really easy. So with some tweaks, we hope that we can do that in the future. But one conflicting thing that we notice immediately would be data that's answered in both data sources. So like, let's say we have a question answered in Duke OIT's knowledge base, but then we upload a new knowledge base and it answers the same question, but differently. We need to still figure out how to train the bot to pick the correct answer between the knowledge bases. So that's all we have for you. Thank you. Are there any questions?